be delivered by Mr. Ishan Arora, Manager Quality at MAHLE Anand Filter Systems PVT Ltd, with over 13 years of rich industry experience in automotive and manufacturing sectors. He is a Six Sigma Green Belt certified professional and has received multiple national level awards for quality improvement, defect elimination, and process excellence. In this session, he will share valuable industry insights on quality management, Six Sigma, DMAIC methodology, and real life case studies, helping participants bridge the gap between academic and industry practices. Welcome, sir, in the session.
Thank you, Tanampreet. Hope I am audible.
Yes, sir. Now I request to all the participants to please mute yourself to avoid disturbance. You may unmute to ask questions. Thank you, everyone.
Tanampreet, can you please confirm my screen is visible?
Yes, sir. Your screen is visible.
Okay. So first of all, thank you for giving me the opportunity to share the topic type of filtration and oil filter assembly and working. So I hope everybody is available and we can start.
Yes, sir, you are audible.
Okay, thank you. So if I talk about myself, my name is Ishan Arora. I'm a quality and manufacturing professional with 15 years of experience in automotive and manufacturing industry. I am specialized in building robot quality systems, driving zero defect culture, implementing practical Six Sigma solutions across shop floor and management levels. So I have experience in IATF 16949, customer audit, supplier quality development. In my tenure, I have completed 5 Six Sigma projects. There were 3 zero defect projects and 2 were related to productivity, complaint management, process failure mode analysis, APQP, FPC, MSA. Nowadays, as you all know, that we are focused on digital quality transformation. There were earlier time we used to record the data on the register or any setup record. Now all the setup manual record has been converted to digital quality. So we have developed complaint portal, dashboard, data driven. We put our rejection, for example, we put our rejection in the software, automatically PPM calculate and the MIS reflected on daily basis. After that, we can come to know the defect and we can take the action. This is the digital quality transformation. We can make a decision making. So I have been recognized consistently achieving the 0 ppm, improving the customer ratings, translating the complex quality concept into simple and educable practices. So this is all about myself. I have worked in companies like Bharat Forge, which is the manufacturer of crankshaft. Then in automobile industry, I have also worked in air conditioning and refrigeration. So first of all, this session is about the practically. I want the students understand the practicality of the concept. They should know what I am thinking about. So this is the Jimny vehicle. Uh, I hope everybody is aware about Maruti Suzuki vehicle. This is the Jimny vehicle and this is the oil pan. And we are manufacturing the filter. This is the filter assembly in the oil pan. and this is complete engine. So oil pan is not visible here. It is near in the engine. When you will open the engine, then you can see the oil pan and the oil filter. So I will start with the introduction of oil filter. There are many types of filtration like oil filter, air filter, fuel filter. So today we will cover oil filter, which is the most important, and we will discuss in detail each and everything about the oil filter. So oil filter is used to remove organic, inorganic contamination from the oil, which is generated from engine working. Organic contaminants include bacteria and other organisms from the gross sludge. Inorganic contaminant consists of dust that ingested into the engine, along with the trace amount of wear material, bearing, and internal moving parts. So the contaminant, can you please
ਉਹ
mute?
ਜੋ ਜਾਣਾ ਫਿਰ ਮੁੰਡੇ ਲਿਆਉਣ ਦਾ ਟਾਈਮ ਹੋ ਜਾਂਦਾ ਸਮਝ
Currently, can you mute the person? Thank you. So the oil filter is used to filter the lubrication in
Sorry
the
to interrupt, sir. I
yeah.
request to participants, please, can you mute yourself? Thank you.
Okay, thank you. So oil filter is used to filter the lubricating oil in the IC engine, internal internal combustion engine in motor vehicle, stationary engine, agricultural equipment, and various off-road engine applications. It is used in light aircraft and naval vessels. So basically, what is happening in the engine? We have a contamination and wear and tear on daily basis. So what oil filter is do to remove the organic contamination? Oil filter also used to filter the transmission oil in hydraulically operated machinery such as lifting mechanism, power steering, and various industrial applications. Now, we will discuss about the history of the oil filter. Initially, automobile engine did not use any oil filter because of low quality of oil. Very frequently, oil changes were required. The first oil filter was very simple. A strainer was placed at the oil pump. The development of high-speed engine pressure lubrication brought the need of some type of filtration to protect the oil pump damage and excess wear. On November 27, 1923, American inventors Mr. George and Ernest filed US patent 1721250 for an automotive filter, and they named the new product Purolator, a combination of one pure oil. Later on, the Purolator oil filter was the first oil filter invented for automobile and in the filtration industry. Most of the oil flow directly from oil pan, which is the oil pan. I have already explained oil pan, to the engine working part, and a smaller proportion of the oil was sent to filter via second flow path in parallel with the first. So the oil is pumped from the oil sump. This is the oil sump. This is the oil filter. To the oil filter, and then distributed by the oil passages throughout the engine. This is the oil sump. The oil filter is going there. It is filtered and it is going to all the paths to avoid wear and tear. The oil enters the oil filter under the pressure to inlet hole. We will discuss in the subsequent slide how the oil filter is emptying in the oil and how it is distributing. And then it passed through the paper. Clean oil come out of the phenol filter and supplied back to the engine for smooth working. Now I will discuss about the oil filter function. So the oil filter function is the separation of solid particles maintain the lubrication capability of the oil, which avoid any wear and tear of all the moving engine parts and components. Maintain the oil supply to the engine through bypass valve, ensure that oil is available when the engine is cold or when the service interval has been significantly exceeded and the oil filter is very dirty. The oil discharge protection. The return flow valve ensures that the filter and the oil channel do not empty when the engine is switched off and the oil is readily available when the engine is started. Because if oil is not available, the engine will get seized. So the full flow oil filter are standard on most engines because 100% of engine oil passes through them in normal operation. The filter must work without introducing a lot of restriction or else the oil will not flow into the engine during the whole startup. This is the one reason the full flow filter allow the passage of the comparatively small to catch everything whose resist flow. If the blockage in the filter, if there is a blockage in the filter, maybe the contamination or uh, suppose when we are going to we purchase a new vehicle after 10,000 kilometers, we replace the oil filter. A person has not gone for the service and the oil filter got blocked. So this does not mean that oil will not flow because it will lead to the engine seizure. In that case, the bypass valve, I will explain in the subsequent slide, will open and the bypass valve will allow the oil to go around the filter and back to the engine. So that engine should not be seized. Some contamination goes to the engine, but lubrication will be unfiltered. The oil is better than no lubrication. You can note down this point. The oil is better than no lubrication. That is, the bypass, non-bypass filter is given so that the oil supply should be continuously to the engine, to the camshaft workshop. So bypass filter take a small portion of the normal oil flow, usually 5 to 10%, and subject to additionally cleaning. Bypass filter can separately from full flow filter and nothing to do with the bypass valve. Now I will explain the child path. What are the child paths we are assembling in oil filter and what are their functions? First of all, this is the main housing, which is we say that filter housing. This is the oil filter housing. This is the pressure spring. This is the cylindrical element. In element, there are four child paths, and this above inboard frame, which means hey, we used to say the center tube. The paper, which is the heart of the filter, the main part of the filter. The paper, the filtration, multi-layer fleet, what we say. And this is the bypass valve, which we say the flat heel valve assembly. Now the check valve. This is the check valve in red color. The cover this assembly. The inlet hole where the oil enters and the cover this assembly. And the gasket which is used to seal the oil filter and the oil pan. Now we will understand uh, the function of each and every child part so that you can understand how the oil filter works and what are the function of the child part. So if I talk about the ring, the fast healing ring, this is the ring, the gasket. It provides the healing between the filter and the mounting adapter. Mounting adapter means the oil pan. There is the this is the oil pan, this is the filter, and gasket is assembled here. It provides the healing between the oil filter and the oil pan. Now I talk about the cover disassembly. The cover disassembly consists of fixing ring. We hold the cover gasket because there should be an area where the ring we will fit the gasket. This is the cover disassembly. The hold the cover the gasket and enable to make the double lock seam joint. Seam joint we will discuss in subsequent slide. This is the cover this. We provide the passage to oil flow and provide the mounting thread or assembly. The form heating ring allows the only unidirectional flow of oil because we cannot allow the dirty oil and the clean oil enter into the oil pan, which allow the unidirectional flow of oil. Now, if I talk about this element, which is the most important, the element have and this above. It provides the support to the paper. This is the paper. It provides support. This is the end this above. It is assembled here. This is the end this above. It provides the support to the paper. It provides the guide to form filling. It guides the element to remain in the center of the assembly. All these parts should remain in the center of the assembly. The adhesive. There is an adhesive in the bottom cap and top cap. The adhesive provides the sealing between the paper and the end disc. There are two end discs, top cap, bottom cap, and this is the adhesive. It provides the sealing. Inboard frame, which is center tube. This is the inboard frame. The center tube provides the support to the filter media and allows the oil to pass through. Because media is paper and paper should have some support, and support is given by the inboard frame, which is the center tube. Multi-layer sleeve. It provides the filtration. These are called the multi-layer. You can see this is not a plane. These are the multi-layer film, and it provides the filtration. Healing clip provide the healing and the paper both end. The flat sheet wall provide the guide to pressure swing and allow the oil to pass in case of filter choking. The fast it provides the guide to pressure swing and allow the oil to pass in case of oil filter choking. If my oil filter is choked, it will help me. It will open. This is the spring. It will come down and will open the bypass valve. This is the spring in the flash fill assembly. The valve spring to control the opening or release valve. The valve plate by passing the oil in case of excessive pressure. And this below. It provides the support to the paper, guide element to remain in the center of the assembly. Now I have talked about the pressure spring. This is the pressure spring. The pressure spring provides the support to the cylindrical element and ensures the sealing between the clean and the dirty oil. Because if we not provide the sealing between the clean and dirty oil, then there is no use of filtration. Filter housing is like as a container, and it hold all these child parts in the filter housing. Assembly seaming. Now I will discuss about the seaming in the next slide. First of all, we can discuss about the gasket sealing. How many? Because this is the gasket. This is the same oil filter we are using in chimney, in Swift, in Vananda. All these type of vehicle, the oil filter is common. So the gasket, there are three type of gasket. Square gasket without lip, square gasket with lip. There is a lip. Lip is here, with, below the cover assembly. Half round gasket with lip. Normally, oil pressure ranges from 5 psi to 100 psi, depending upon the engine and the design. Most of the engine pump oil take at exceeding the gallon per minute. You can quickly understand if the gasket
यशवी
is
वो आंटी ना इसको चलने देना, ठीक है बेटा?
you can quickly understand if the integrity of the gasket is lost, all the oil in the engine will be lost in few minutes. So it can make the engine failure. So no matter how good your oil may be, the base gasket is most important part of phenol filter. Being a rubber part, the gasket material has inherent property of deterioration with the time. With the course of time usage, it will either harden or soften. It depends upon the oil temperature, the engine vibration and all. All the oil will be lost. So quality and the material of the base gasket is very important. Depend upon the engine condition also. We determine the life because when we have decided it should be 10,000 kilometers. It based upon the validation, the testing, and the material of gasket we are using for sealing. So there are three types of gasket we normally use. Nitrile rubber. The temperature range from minus 30 degree to 120 degree Celsius. Normally engine temperature goes to 100 degree Celsius. 100 to 110. Acrylic rubber. This is more soft and more better than nitrile rubber because it can withstand to 150 degree temperature. Minus 40 to 150 degree temperature. Silicone rubber. It is more better than nitrile and AEM, which is minus 30 to 170 degree Celsius. But it is very costly, it is less costly, and it is very cheap. So, so it depends upon the engine temperature conditions and the cost involved in the oil filter. Anti-rain wall. What we talk about anti-rain wall, the check wall. The anti-rain wall applicable when the filter is mounting such that oil tends to drain during the engine off condition. Now the engine is not in the off condition. We suppose we have parked the vehicle in the parking. The engine is off. So there is the check wall which used to drain during the engine off condition to hold the oil in the filter after the engine or lubrication is shut down. This is done to avoid the delay in the oil pressure. Buildup once in the system is restarted. Without an anti-rain wall, lubricated oil has to fill the filter before traveling to the engine moving part. Because when we will own the vehicle, the oil should be there. Otherwise, engine will get heat. The situation can cause premature wear and tear of moving parts due to the initial lack of oil. Dry run. Dry run means engine is running without oil. Being the rubber part, this is also the rubber part, like gasket. The healing material has inherent property with the deterioration of time. Same thing applicable to check valve also. With the course of time and usage, it will either harden or soften depend upon the oil we are using. The OEM is using. OEM means Maruti, Honda, Tata Motors, Mahindra, all the vehicles, automobile engines they are using. The quality of material of the form sealing is what determines the drain wall function. Same thing is there that nitrile rubber, AEM and silicone. Mostly we are using the silicone as a check wall. Now another child part is the cover assembly where the oil enters. The oil is entered from this small hole and coming out from this big hole. So we will understand what is the cover disassembly and what are their function and how it is used in oil filter. So the cover disc assembly consists of two parts, the ring and the cover disc. The ring is assembled here This is the cavity where we are assembling the ring, the gasket, room for gasket. This is the thread because whenever we are mounting the oil filter on the oil pan, the thread is used, the male and female part. This is the oil pan. It is assembled here. The groove is to fix the healing gasket. Grooving system must be free from burr. There should not be burr because if there is any burr in this area, it can cut the gasket. The inlet holes are equally placed inside the filter because the oil have to enter from the inlet hole. All the oil must be 1.5 times minimum of the outlet hole area of stud. Mounting thread to fix the filter with engine block or adapter. Now fixing ring is made of cold drawn steel sheet, drawn quality electro zinc plated. So that we have to protect our cover plate from the rust. So it is zinc plated. Using the 50 ring groove have for gasket heating and oil flange for double lock rim. Normally dimension configuration have the tolerance. So it is so precise that the tolerance we are maintaining is plus minus 0.1 mm for groove hitting area and the flange length. And the flatness we are maintaining in 0.1 mm. Now the most important, the critical operation. How we are healing, because you can see that when we assemble the cover assembly have the healing with the housing. This is what we call the seaming operation. It should have seam with the housing. So this is the animation. You will understand. This is the bowl. This is the cover assembly. So in the first operation, the shape is like this. In second operation, it got completely sealed like this. So we will understand in deeply what I am trying to say. When first operation hemming roll profile form, the material in the retainer and the bowl. The second hemming operation profile will successfully compress and form the ideal final seam. The first operation, this is the seam hook. The first operation must have performed correctly in order for second operation to finish the seam. The first operation is a major key in controlling the retainer hook, which partially controls the bowl hook formation and the counter shank depth and the degree of wrinkle in the retainer hook. The first operation, seam operation, will also control to degree the final seam height. A narrow roll profile will result into the second operation, seam height. The seam height, I will make you understand what is the seam height, seam thickness. A use of thumb rule is observe the bottom portion of first operation seam. The retainer collar should form the smooth radius and come as close to contacting the bowl wall as possible. Maintaining the smooth radius without slap spot or the sharp break into the bowl body will assure a good condition for seam. As a best practice in initial setup, it is highly recommended to back off the second operation roller and form the first operation. Without properly form the first operation seam, it will be difficult to obtain the acceptable finish seam. This is the actually we have four rollers. In first operation, there are two rollers. In second operation, there are two rollers. There are four rollers. And this is the chuck. In first operation, it seems like this, only giving the shape. This is the this is the seam width, this is the seam height, and this is the counter hung, and this is the retainer. This is the first operation. So you have seen the animation that it's only the pressing the whole bowl and the cover assembly. Then in hacking operation, it is giving the shape. The hacking operation heaving process flatten the seam, pressing the fold of metal together, tighten enough to compress the healing compound, which fills the void and the area of the seam not occupied by the metal. The ideal hacking operation seam should be well wounded, with no sharpness in the upper portion of counter chunk, no distortion of crashes all over the seam. The thickness of the double seam is approximately the sum of 3 times the retainer thickness and 2 times the bound thickness. I will make you understand. This is the retainer. This is the seaming which I am talking about. The, this portion was seamed with the bound. I will share the video. The chuck is coming. The two rollers are doing their first operation. They are shaping the seam, and in second operation, they are completely joined. The pressure ridge should be closely examined to proper analyze the seam. Visual seam is important, but not adequate to determine the quality and the integrity of finished seam. A cross section of double seam is the first operation, and the normal second operation will show the good overlap with very small void at the end of the both the retainer hook and the bound hook filled with the sealing compound. So hope you all guys uh, drink the Coke bottle, the Coke can. The Coke can also the same the seaming operation like in oil filter. This is the seaming operation, the seaming chuck, and it should be completely seamed. Otherwise, the oil will come out from this seaming, and it can create a customer complaint. The leakage can be happen if the seaming operation is not okay in the oil filter. So this is the theory. Now I will share the actual what I am trying to say. This is the chuck where the oil filter sits. These are the rollers. 1, 2, 3, and 4. This is the first operation. They come closer to each other. They seam, and second operation they seam they do the final seaming. The cam revolves and it is connected to the main motor. It is on the back. The main cam motor on the top of seaming head. The seaming arm moves in the same direction but attached to the another gear so that rotation speed is different as compared to the cam. The seaming arm is attached by the roller. This is the arm. This is not visible here, but this is the arm. It is attached by the roller. And the roller bearing, which is follower of the cam. The seaming arm is stationed on a pin joint ring. At the end of the arm, the roller is mounted and is set at a particular distance from the chuck. This is the chuck. This is the distance the roller is there. For the, for the final part of roller is radially in, out based on the position of the bearing of the cam profile. So that because what we are doing, we are only pressing the roller so that seam can be done and there should not be any leakage. So the maximum pressing of roller is set when the bearing is on the highest position on the right of the cam profile. So this is the seam, and now when we are doing the seaming setup, so this is the most important. We are checking to ensure that it is leak free. What we are calculating the overlap percentage. That is B upon D into 100. Now we will understand what is the A, what is B, what is D, what is C. A stands for the vertical distance between the topmost and the bottommost surface of the seam profile is known as seam height. A is the seam height. B is the distance between the retainer and the bound collar. The bound and the retainer. C is the horizontal distance between the innermost and the outermost seam profile. Is seam thickness. D is the maximum distance between the intersection of bound and the retainer, which is D, which is most important. So what we are doing the B upon D and into 100. So overlap percentage is the main driver to calculate the strength of CA and bound. So what we have taken, if we are doing the setup, we have to do the setup, we have to do the adjustment in the roller and the chuck. They should be aligned. And after that, we are calculating the overlap percentage. And it should be minimum 55%. If it is less than 55%, this means there is a possibility that leakage may come. And if a leakage may come, the oil will get leaked and engine gets heat because oil will get drained from the oil filter. So this is the minimum overlap percentage we nowadays we are in industry is 55% and a acceptable standard, and if it is above than 75%, so it is very better and it will not be leaked. So it all depend upon the variation of the child path, the variation of the gasket. After that, we have make the standard. This is 65%. Now, I will see here how we are setting the procedure. So we are mounting the chuck in the steaming machine. Then we are mounting the first operation roller on the hemming arm. We are adjusting the height of the roller because we are manufacturing bigger filters. Some have 70 mm, 80 mm, or 100, 120. So it depends. We have to adjust the first operation roller on the hemming arm. Adjust the height of the roller so that the knurling above, it should be above the knurling wall of the chuck. There is a knurling in the roller. Then we are bring the roller near to the cam of the hemming arm to the maximum light position. This is the cam. We are uh, making the closure. We are adjusting the screw of the bottom half of the arm to move the roller inward. This is the knurling which I was talking about. We are setting the required pressing of roller. After setting, we are tightening the bolt to the lock pressing of the roller. Now this is the chuck, this is the roller, now they are aligned. This is the chuck, this is the roller, now they are aligned and the path is near. So we repeat the process till all the four rollers are mounting on the hemming head. Now, I will share because the hemming is the most important operation in the oil filter. So we have understood the failure mode we are getting in the hemming operation. So this is the automation how we are controlling in our manufacturing process because any operator which is not skilled, he should not operate the hemming machine because whenever the hemming machine we are doing the setup, we are manufacturing thousand number of parts in 1 hour. And if there is a mistake in the hemming setup, the rejection will occur in thousand number. So what we have done, we have done the interlocking in hemming machine. And this is the biometric. So we have done the biometric interlocking on the hemming machine. The operator have to sense their fingerprint. Only then the hemming machine will run and part can be produced. Otherwise, the HMI will give machine and the error. Machine access permission not granted. Please access the biometric devices. So this is the way we are protecting that unauthorized operator on operator which is not L4 level, which is not L4 level is operate the saving machine. There are four levels in our company of operator like L1, L2, L3 and L4. L1 means very low skill operator. L2 means having the experience for 1 to 2 years. L3 means having the experience 2 to 4 years. L4 is more than 5 years. So this is one of the control. The hemming machine only operates when the authorized operator will scan with finger here and HMI will give the healthy and it will denote the L4 level and then only the hemming will start. Now there can be one question that we are supplying to many customers. So roller will be the difference. So to avoid the mix-up of roller, what we have done, we have displayed the QR code on the roller. And this is particularly model like 4495, 4580. To avoid the mix-up of the roller, we have we have displayed the QR code. So we are doing the scanning of QR code. If we are scanning this 4495 and the program is for 4495, only then machine will start. Otherwise, machine will not start. If we are scanning 4580 and the program is 4495, the hemming machine will not work, will not start. So this is the we have done the roller interlocking through QR code on the hemming machine to avoid the roller mix-up. So interlocking of roller through QR code is available on hemming machine. Operator have to scan QR code on the roller and it should match with the model program running on HMI. Only in that case, the hemming machine will operate and prevent the wrong model roller assembly. Now, the maintenance is very important. In earlier time, we were doing the maintenance, we were maintaining the hard copy. Now, what we have done, because some points we have to check on daily basis, and some point we have to check on after 4 months, after 6 months, like that. So there are two types of maintenance: autonomous maintenance, which we are doing on daily basis; preventive maintenance, which is 1 year. So what we have added the autonomous maintenance in HMI. So operator have to see the condition that assembly is cleaned properly, it has tightened properly, the roller is okay, the pressure is okay, all these type of basic requirement, all panel should be closed because if panel is not closed, there is a risk of safety. And this is the autonomous maintenance operator have to click OK. In case any one parameter is NG, not OK. In that case, machine will not run. And this is the PM interlocking because the due date after 10/10/2026, machine will automatically shut down. For that, we have to do the PM. After PM, it will come okay. So AM check sheet, autonomous maintenance check sheet, fill in machine, and PM tester. In case any checkpoint not okay, the hemming machine will not operate. Now, it is obvious that whenever we do the setting, their setup paths are there because we have to align our roller with the chuck. So there is a possibility that setup path got mixed with the OK path. And we have got many customer complaints regarding this, that our setup path mixed with the OK path. To avoid that, what we have done, we have added this pop-up in our HMI, in our hemming machine, that in setup path have to be rejected and they have to be put in the rejection bin. And in the rejection bin there is a sensor. When we put the 7 path in rejection bin, only then the hemming machine will run. Otherwise, hemming machine will not run. This improvement only done to avoid the mishap of setup path with the OK path. So pop-up is there. This is one of the example. At 19:126 at 12:09 p.m. the setup, the operator has done the setup and seven paths have to be rejected. Otherwise, the machine will continuously pop up. Wait for path quality check approval. Otherwise, the hemming machine will not work. Now I will talk about the elements because it is the heart of the filter. The main function because how oil is clean? Oil is clean through paper. The main function of oil cleaning is to clean the oil. The element contained which we completely call the element. The element contains filter medium closed from both sides with the help of additive, which I have explained. There is this upper plate, lower plate. It provides the largest possible surface area with regard to optimal filtration and long service life. It is important that the filter element demonstrates the high mechanical strength. To achieve the mechanical strength, the end cap on both sides, the inboard frame must be called the center tube. Is used to center the, the paper to give the strength to the element. Even at even at high differential pressure or we occur during the cold start because during the cold start the pressure is very high. The filter media is changed over the time. Earlier designs were used steel wool, wire meshes, metal screen, cotton, various woven like linen was used. Now cellulose paper was used to minimize the production cost. What is the difference between the duplicate filter and the oil and the original filter? We have seen in the market all filters are available. Some people duplicate what they are doing, they are using the normal paper. With doing nothing. They do not filter the paper. They do not filter the oil. So the filter should have the proper cellulose paper or any other media. The disposable phenol filter use the cellulose filter media. The cellulose filter media. Better quality of filter use the synthetic media, while top end oil filter use the micro glass or extremely the fine metal touch. Now I will explain the technical terms regarding the paper. There is a slip width, the cutting width and the correspondence tolerance which are defined by the short test regardless of own production. So the slip width, this is the slip width. It should be less than 100 mm, 150 mm to 50 mm. The configuration and the tolerance of the plating are defined by product drawing or the basic drawing. The height of the element, the tolerance of the height of the plating has to be defined according to the tolerance. The pleat depth, the smallest pleat depth is 6 mm and the maximum we can go for 50 mm. The number of pleats, this is the number of pleats, 1, 2, 3, 4, 5, 6, 7, 8, all total of pleats. So tolerance is given plus minus 2. Basically, the oil filter we are using in the MSIL vehicle or any Honda vehicle, so we are keeping the fleet 65 plus minus 2. And this is the pitch, the result of filtration area with the maximum paper thickness and the diameter, outer diameter of the inner frame, dA. So the paper media have embossing, the dimpling, so that the pleat spacing remains stable and strong. It prevents the bunching in which the paper pleats consolidate into the block and reducing the filtration performance. If I talk about the clip, so there is a clip in the element. The clip is from aluminium because we have to close this. For closing, we are using the aluminium clip here. And there should be the equal gap between the number of slits. Now I will talk about the center tube. The center tube, the height, it must be less than the height of multi-layer slit because the slit will come on the center tube. The center tube height must be less than the multi-layer slit by 1 mm or maximum to 1.5 mm. The dimension of the inboard frame is defined by the diameter. The inboard frame is with overlap and the position of overlap must be defined with the define of the diameter. The system of a correspondence tool needs to be checked. For the tolerance for diameter, roundness, and rectangularity are defined directly or by general tolerance, depending upon the necessity. The punching bar inside should be inside. This is the hole in the center tube because whenever the oil goes from this embossing different media, it will go inside this inner hole and it will come out to the main hole, which I have explained earlier. Now the end cap. The main job of end cap is to retain the end of the media. If I talk about the adhesive, the kind and amount of glue is defined by the bill of material. The height of glue in the glue. Because elements have to be sealed with the end cap. For that, we are using the glue. The glue height should be 2.5. The height of glue should be 2.5 mm to 3 mm. Now, I was talking about the bypass wall. Because when the filter is choked, uh, the oil is not passing through the oil filter, there is a risk of engine failure. So what we open the bypass wall. Now I will talk about the bypass wall consists of four parts. The cage, the wall spring, the wall plate. Usually the lubrication system incorporates an upper pressure relief valve to avoid because it will increase the pressure in the oil filter. Whenever the pressure will increase, it may impact the seaming or it can burst the oil filter. To protect that, the bypass valve is there, which is the relief valve to allow the oil to bypass the filter and if flow resistance is excessive to protect the engine from oil starvation. Filter bypass may occur if the filter is clogged or the oil is very thickened in the oil cold weather. The upper pressure relief valve is commonly used in the oil filter. This is the assembly of this bypass valve. This is the bypass valve and this is the end cap. Now I will talk about the pressure swing. Pressure swing, this is the element, this is the center tube, this is the pressure swing. The pressure swing, this is the pressure swing. This is the RV, but the bypass one. The pressure swing holds the element even in vibration condition and ensuring the healing between the dirty and the clean oil through anti-drain wall or gasket. The pressure swing must be greater than 1.3 times of oil inlet pressure, less than 1.3 times oil inlet pressure to ensure no movement of element through working condition. Normally, the dimension of computation of tolerance are defined only in drawing. Now I talk about the housing and glue. Because whenever we have to assemble the oil filter, the glues are very necessary. Otherwise, because we are using the torque wrench, what we call the facet, and this is called the number of facet. The filter housing is made of sheet metal, deep drawn, and it is also the powder coating to prevent it from rust. It is only the visible whenever we will see the engine, it is the visible portion, and it has many facets of glue as per customer requirement. The pin-on assembly. The tolerance must be defined only in drawing. The critical tolerance and the radii must be followed. This is one of the examples, the height we are measuring. This is the dia, This is the number of phase and it should be equally phased. Normally we are using the progressive tool for making the equally phased. Now we are checking the water the oil filter in the water leak testing, and this is one of the animation because one I have already explained that first of all we are checking the overlap. That overlap should be greater than 55%. After that we are checking the oil filter in water leak testing. The water leak testing starts. These are the filters. These are the filters deep in the water, and this is the meeting part. This part. Now, what we assemble the oil filter in the picture, and we see the oil filter. There should not be any leakage in the oil filter. So the air, when we start the water leak testing, the air will flow from here. If we go inside, if we check all the sealing portion, no leakage, and it will come out. So no leakage should be there in the oil filter. So we have developed the new the WLT fixture so that we can check the oil filter leakage in water leak testing. The pressure we are maintaining in the water leak testing is to 6 to 7 bar, and the testing time we are using in the water leak testing is 30 seconds. Now I will share one issue we have faced in oil filter in one of our clients. The issue was the pressure, the input pressure and the output pressure. The pressure was low. The delta pressure is very, very low. So the IPD, initial pressure drop on higher high within the tolerance. So there can be many reasons. This is the faulty analysis which we have noted down that the cover assembly, there may be possibility that cover assembly is not as per drawing. Why? What can happen? The number of inlet hole. The number of inlet hole. I will explain again. These are the number of inlet hole. The oil enters from this inlet hole. The number of inlet hole not okay. Inlet hole may be the block. The diameter. No, inlet hole is not okay. They can create an obstacle of, for the oil, and for that obstacle, there can be issue with the initial IPD, the initial pressure on higher side. Now the element which we are using is maybe not as per drawing. The number of fleet we are using in the element, there can be the in damage condition. The number of fleet, this is the number of fleet, this can be in damage. The paper media, because we have mean for the minimum particle which can enter into the media is 1 micron, 2 micron, or the maximum particle which the media people can allow. So there are different media in the oil filter. There is a possibility that the media which we are using one customer is by mistake assembled in the other customer. The third possibility is there can be a congestion. I will explain this in subsequent slide. There can be the congestion in the fleet. The center tube, which I have explained, the center tube. This is the center tube. It's not advertising means the whole ID is not okay. The center distance between the hole is not okay. Or there can be a forum change in heating process. So we can explain the possible causes that this is the drawing picture. I have explained that the hole 4.5 dia equally phased. It should be equally phased, and the PCD, the pitch circle diameter should be 31.5. So whenever we got a complaint from one of our clients, we have checked that the holes are okay. They are equally spaced. And the thread height also okay, 3 by 4, 16, UNF to B. So this is the number of inlet holes we found okay. Now, also we have got the customer return path. In customer return path, we have observed that the holes are okay and this is non-significant cause. This means the pressure drop is becoming high. The limit was 0.38 bar. It was coming 0.4. It was coming high. It's not due to the common assembly. Now the possible cause 2. There is a possibility that inlet hole blocked. There is a restriction in the inlet hole. So we have checked the 5 paths and also checked the customer return path. So we do not find any blockage in the inlet hole. So the IPD is not due to the inlet hole. If I talk about the inner diameter 4.5, we have checked the diameter of inlet hole. So diameter was found 4.47, 4.46, 4.47. In return part also we have got the diameter 4.47. The tolerance is 0.1 mm. This means the running part, the customer return part, and the drawing, they all are matching. So no problem in the diameter of the inlet hole. Now, I have explained that number of pleats there may be the paper damage. The number of pleats got damaged. So we have checked the return part, the running part, and the standard. We do not found any damage in the element. So this is also the non-significant cause. Now the most important, the paper element. It should be as per drawing. The mean pole, max pole, thickness, all we have checked and all found under specification. So IPD is not due to the media is okay as per requirement of the oil filter. Now I will talk about the congestion in the fleet. The congestion. I'm also explaining because I want the students should understand the practicality. They have understood the oil filter working and all. Now they should understand the practicality. What's the issues we face in the oil filter and how we are resolving. So this is the element. So what we have seen that there is a congestion. There should be equal distance between the pleats. But congestion is there. The template congestion is there in the element. And this is the machine, this is the oil filter, we are checking the pressure drop. This is the inlet, this is the outlet, and we are checking the delta. Outlet minus minimum, we got this specification. And this is the congestion. These are the 10 pleats which are together. It should not be, there should be some distance between the number of pleats. And these are stick together, which is creating the congestion in the fleet. And this is the total 20 pleat congestion, increasing the pressure drop. So this is one of the significant cause we have found in the oil filter. Now I will explain how the congestion is impacting the IPD in detail. This is the oil. You can see in golden color, the golden dot. The oil is entering in the fleet, and this is the oil output. So number of fleet required was 73. So there should be smooth flow of oil, but due to this congestion during the transformation, the oil was not flowing smoothly. The congestion was there in the element, the congestion. And we are observing the high pressure drop after the filtration. The oil is coming here at some pressure. After the filtration, we are facing the high pressure drop because the congestion is there in the filter, as I explained in the photograph. So the congestion of oil should not be able to flow, the oil not able to flow properly due to the improper, what we call the star formation. This is the star formation. This is the improper star formation. As the distance between pleat to pleat is very, very less. So this creates the pressure drop issue. Now we have done the simulation trial. We have made a filtration area required as per drawing in 900 square centimeter, 811 square centimeter, and filtration area 800 square centimeter. So we have taken a total 90 samples and we have checked the IPD. So we have implemented Six Sigma tool so that we can come to the conclusion how we have to maintain the number of fleet, how can we eliminate the congestion, how can we eliminate the customer complaint, how can we eliminate the warranty issues in the field due to the oil. So at 64 fleet, we have made 30 samples. 68 fleet, 68 fleet, we have made 30 samples. There actually the area in the drawing is given 800 to 900 square centimeter. So we have a wide tolerance, but we were supplying oil filter with 73 fleet, not with 68 and 64. So the number of fleet we have taken the Six Sigma Green Belt project and we have implemented one tool. So we have taken a sample of 30 fleet and 811 square centimeter area which consists of 64 fleet, 30 fleet with area is 61 centimeter, 30 fleet with area 900 square centimeter. So what we have found that the IPD we are getting less when we have an area of 64, which is minimum we are getting 0.20 and maximum we are getting 0.24 against the pack of 0.3. When we are going for a 61 square centimeter filtration area means the number of fleet which is 68. The number of samples we have taken 30 and we have got slightly high IPD which is 0.24 and the maximum we are getting 0.27. Then at 900 also the high 0.24 and 29 which is again at higher side mean my tolerance is 0.3 and we are manufacturing the oil filter at 0.29. So what we have used the regression analysis. Regression analysis is one of the hypothesis tools we are using in Six Sigma Green Belt. So in Six Sigma Green Belt, we calculate the R square value. Is there really a significant interlinkage between the number of fleet? Yes. The graph itself saying that at 64, IPD is 0.24, 68 it is 0.28, and when we go for 73, it is 0.29. This is the limit. So from graphically, you also able to understand whenever if we increase the fleet, the pressure drop increases, the congestion increases because at 73, the distance between the paper is very very less, and it creates the congestion and increase the IPD. So we have discussed with the customer and we have made the gone for engineering change management. We are in the tolerance. We already in the tolerance. So we have requested our customer that we will maintain this as 68 because when we are manufacturing element at point 3, so there is a possibility it will go beyond the limit 0.32, 0.34. But if we will maintain at 0.24, So there is a very, very less possibility that it will go above the limit of 0.3. So from the regression analysis, we come to the conclusion that when number of leads reduces, the congestion reduces, and when the number of leads increases, the congestion increases. So this is the Six Sigma methodology we have adopted in the to counter this issue. So this is the difference between the number of leads 66 and number of leads 73. That whenever we are using low number of leads less, so you can see there is no congestion. The oil input coming from here and oil output there is okay pressure drop the 0.3, which is the requirement of the drawing. And after that, we have not received not a single complaint from one of the clients, and we were facing issues in warranty and in manufacturing 0 kilometer complaint. And this is the 73 number of feet, which is the high congestion, and congestion was there because the number of feet are so high that in this area they are stick together and the oil not able to flow properly from the element. So if I talk about MSIL comparison means the other customer, we have also explained our customer that we have a design with number of 43. This is the Honda design we are using. The number of trees is 40, only 40 with no congestion. 64, almost no congestion. All there is a gap between the number of trees. And 73, which we are using a higher spec. So much congestion is there, and we were facing the oil pressure drop issue. So we have also checked the center tube hole ID. The center tube hole ID is okay, 2.45, 2.44, and also one of the this is not the hole. Center tube whole center distance because there are I hope you remember the center distance center tube. This is center tube. The ID their distance also important in the filtration. So we have also checked the center distance of the center tube and the whole center distance observe 4.8 plus minus 0.1. We are observing 4.80, 4.79, 4.80, 4.78, which is running in okay parameter alpha, though this is the non-significant one. So from the all the possible causes we have simulated at our end, and we have got the most significant congestion. And number of inlet hole, if we related to cover the heavily inlet hole block, 8 hole diameter, found okay. Element found okay. Only congestion in element was the most significant cause. Center tube, which we have explained, the ID not okay, found okay. Whole center system not okay, found okay. So the combination also confirms that congestion in the element play a major contribution role in the pressure drop. So we have again relationship the congestion with number of lead and filtration area. So somebody can ask me how number of lead, how can impact. So we have again taken the area different 55, 56 and 73 and the lower pressure drop is here. Is here. So the regression analysis we have got the relation of 89.74, which is very, very strong relation, and we have satisfied our customer and we have eliminated our complaint. So I hope I'm able to make you understand the filtration, the component, the seaming operation, how we are seaming, what are the controls we are having in the process, the child path, and the water leak testing function. We are also using the air leak testing to check the filter, and this is one of the example I have here. So if any query uh, want to ask anything, I can. You are most welcome. Hope everybody oil filter is not a vast, but it is very critical and most important, and it should be deeply understood. I hope I am able to make you understand. And any question, any doubt, so you can ask.
If any participant have any question, you may ask, please.
Hello, sir.
Yeah.
Sir, how you are selecting the paper filter and the cloth filter, sir?
Okay. Actually, what's your good name?
Kashinath Tangade.
Okay. So, Mr. Kashinath, what we are getting the Indian specification. Okay. For
Okay,
Indian specification, we got the value of temperature.
okay,
Okay. And what they share with the type of oil. What is the type of oil they are going to use? Like 15W40 is one of the example of the oil.
yes,
15W40. So
15W40.
yeah. So
Okay,
the oil is different. So
okay,
after we are getting the specification from our customer, so we are designing our paper. The minimum particle which we can allow from the oil filter to pass. The maximum micron particle which we can allow to. After that, we are uh, selecting the media on the basis of the specification given by the customer.
okay, okay, sir. Okay.
Yeah. So any other any other question, any other query I can clear, otherwise we can close it. Any closing comment want to share? Uh, any suggestion? Most welcome. So Talampreet, if you want to add something, otherwise we can close. So thank you for the patient listening. I hope I'm able to make you understand the oil filter, the type, and the problem we are facing, how we are resolving. So thank you all. So thank you. For me, we can leave. Can anyone can confirm? Talampreet, thank you.
जी सर,
Thank you.
थैंक यू,
Thank
सर,
you.
नाइस
Thank you.
सेशन,
Yeah,
गुड
thank
नाइट
you
सर.
all. Yeah, good night. Thank you all. Good night. Have a nice day.